Assuming you put Betelgeuse where the Sun is, it would expand to the orbit of Jupiter, becoming a beast of tremendous size, absolutely insecure and primed to detonate. These are some of the most noticeable effects of radio energy in the entire universe, conveying more energy than a billion suns. Betelgeuse, a red supergiant star, is so large that if you placed it where the Sun is, it would extend to the orbit of Jupiter. It's immense, totally erratic, and on the verge of a catastrophic explosion. When we consider stars, we often envision tiny twinkling points of light in the night sky, which is how we see them from Earth. But stars are much more than that. In fact, one of the most prominent stars, Betelgeuse, is far more remarkable than our Sun. For years, this star has perplexed astronomers, but recently, a disturbing trend has emerged, drawing increasing concern among scientists. Join us in this exploration of the fascinating new data about Betelgeuse, its imminent destruction as revealed by the James Webb Space Telescope, and how this discovery will impact our universe and our lives on Earth. As physicist Michio Kaku explains, Betelgeuse is an immense wonder, a colossal star that has intrigued astronomers for centuries. The Greek astronomer Antonius was the first to observe it. This star is so gigantic that it's visible in the night sky from Earth, especially during winter. If you're into cosmology, you've undoubtedly seen or heard about this star. It marks the upper left shoulder of the Orion constellation. Betelgeuse is not only ancient but also one of the most magnificent stars we can observe. However, one of its most striking features is its variability. The star does not remain steady. Instead, it fluctuates in brightness. This change is one of its defining properties, but it's not the only intriguing characteristic. Most stars we observe in the night sky are located far from Earth. The closest star to us, Proxima Centauri, is about 4.2 light-years away. To understand this distance, imagine traveling at the speed of light for an entire year. The speed of light is about 186,000 miles per second, so over the course of a year, light can travel about 5.88 trillion miles, which equals 1 light-year. When we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. However, Betelgeuse is even farther. It's located approximately 600 light-years from Earth. If you were to travel there at the speed of light, it would still take you 600 years to arrive. Of course, we can't travel that fast, at least not yet, but despite the great distance, Betelgeuse shines incredibly brightly in our sky. How can Betelgeuse be so luminous, despite its vast distance? It's because of its extraordinary size and brightness. Betelgeuse is around 10 to 20 times more massive than our Sun, with a radius many times greater. However, despite its enormous size, Betelgeuse appears as a disk in the sky, rather than the point of light that most stars seem to be. This is due to the reactions in the outer layers of its atmosphere. Betelgeuse's mass ranges from 12 to 19 solar masses, but the exact figure is difficult to pinpoint. Without nearby celestial objects to provide gravitational reference points, astronomers can't measure its mass directly from Earth. Betelgeuse's brilliance also fluctuates dramatically, ranging from magnitude 0 to plus 1.6. In layman's terms, this means that at its brightest, Betelgeuse is several times more luminous than our Sun. This variability is linked to its throbs, cycles of expansion and contraction. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These cycles can last anywhere from 10 to 100 days, or even much longer. A unique feature of Betelgeuse is that its surface is covered in dark magnetic spots. These spots create a much stronger magnetic field than our Sun's, but they interfere with the flow of hot gas from the core to the outer layers, which causes the surface to be cooler in those regions. Betelgeuse's magnetic spots are much larger and more numerous than the Sun's, with some spots being twice as large as Earth itself. These spots contribute to the star's lower temperature, which is around 3,500 K, compared to the Sun's 5,778 K. Despite this cooler surface, Betelgeuse remains an immense and brilliant star. However, it has evolved significantly over time. Once a yellow star, Betelgeuse has gradually transitioned into the red giant we observe today. About 100,000 years ago, it was yellowish, similar to the Sun, but over time its color shifted to orange and then to red. This change signals that Betelgeuse is entering the later stages of its life cycle. The fact that Betelgeuse is so far away, 600 light-years, means that, despite its enormous size, its energy output is still immense. If it were closer to Earth, we would be able to see it during the day, just as we see the sun. But if Betelgeuse were placed at the center of our solar system, it would engulf the Earth and the other planets, including Jupiter, because of its massive size. In addition to its size, Betelgeuse also releases far more radiation than our sun, further amplifying its power. Betelgeuse's enormous size, combined with its variable brightness, make it one of the most dynamic stars we can observe. However, like all stars, it will eventually reach the end of its life. When Betelgeuse runs out of fuel, it will undergo a catastrophic fusion process, turning heavier elements like helium and carbon. This will cause the star to expand to even greater sizes before it dies in a spectacular explosion, a supernova. The force of this explosion will be strong enough to dominate an entire solar system and might send shock waves through space. Some scientists believe Betelgeuse could go supernova very soon, though predicting the exact timing is difficult. The James Webb Space Telescope has provided new insights into Betelgeuse's behavior. Its infrared capabilities have allowed scientists to study the star's outer layers and magnetic fields in unprecedented detail. These observations confirm the star's ongoing changes, including its irregular brightness and potential instability. Scientists are closely monitoring these changes, hoping to learn more about the evolution of stars and the fate of the universe. When Betelgeuse eventually goes supernova, it will release its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on Betelgeuse's final mass. A supernova of this magnitude would be visible from Earth without a telescope and would release enormous amounts of energy. This explosion will also create heavy elements, like iron and nickel, which are essential for the formation of planets and stars. These elements will spread throughout the universe, enriching the interstellar medium and contributing to the formation of new celestial bodies. Researchers have noted unusual changes in Betelgeuse's brightness in recent years, suggesting the star may be nearing its supernova phase. Some speculate that the explosion could happen within the next 100,000 years, which is a relatively short time in the context of the universe's life. However, it's impossible to know exactly when this will occur. The death of Betelgeuse will be a momentous event in the universe. It will not only mark the end of one of the largest stars we can observe, but will also trigger the formation of new stars and planetary systems. The elements produced in the supernova will contribute to the creation of future generations of stars and planets. Although we won't be around to witness the event, the study of Betelgeuse provides valuable insights into stellar life cycles and the evolution of the universe. By studying stars like Betelgeuse, astronomers can continue to unravel the mysteries of space and our place in it. The legacy of Betelgeuse will live on, not just in the elements it creates, but also in the knowledge it has provided to generations of scientists. Its eventual demise will remind us of the dynamic and ever-evolving nature of the universe, as new stars are born and old ones pass away. Through the continued study of Betelgeuse and other cosmic giants, we gain a deeper understanding of the vast and complex forces at work in space and our place within this grand, interconnected universe. Betelgeuse, as one of the most fascinating and well-studied stars in the cosmos, holds a unique place in the field of astrophysics. Its location in the constellation Orion, one of the most recognizable and studied constellations in the night sky, makes it an ideal subject for research. Orion, often referred to as the Hunter, is home to many noteworthy stars, but Betelgeuse stands out due to its massive size, distinct color, and the dynamic changes it exhibits. In recent years, scientific advancements, particularly with the help of the James Webb Space Telescope, JWST, have offered deeper insights into this red giant's properties, its behavior, and its eventual fate. As a red supergiant, Betelgeuse represents a stage in a star's life when it has exhausted much of its hydrogen fuel and has begun to fuse heavier elements like helium, carbon, and oxygen in its core. This stage is a critical part of a star's life cycle, as it marks the transition from stable hydrogen fusion to a more turbulent and chaotic phase. The fusion of heavier elements generates enormous amounts of energy, causing the star to expand rapidly. This expansion results in the star becoming many times larger than its original size, often to the point where it can no longer sustain such a vast volume. This leads to the star becoming highly unstable, fluctuating in brightness and size, as seen with Betelgeuse. Betelgeuse's fluctuating luminosity is an extraordinary feature that draws the attention of astronomers. The star's variability is caused by the pulsations in its outer layers, which expand and contract in cycles. These pulsations occur because of changes in the balance between the inward pull of gravity and the outward pressure from the nuclear fusion happening at its core. As the core fuses heavier elements, it generates immense heat, which pushes outward against the force of gravity. However, as the core exhausts certain elements, the balance shifts, and the outer layers of the star begin to contract again, leading to a decrease in brightness. The cycles of expansion and contraction can take place over periods ranging from days to months, and sometimes even years. These dramatic changes are not just a quirk of Betelgeuse's behavior. They are an essential part of its evolutionary path. During this stage, Betelgeuse sheds enormous amounts of material from its outer layers. The loss of mass contributes to the star's eventual transformation into a white dwarf or another exotic remnant, depending on its final mass. This mass loss is accompanied by the star's vibrant shedding of outer gases and dust into space, which enriches the interstellar medium. Over time, these ejected materials may contribute to the formation of new stars, planets, and even life forms, continuing the cosmic cycle of birth and death. This process of mass loss is particularly crucial because it contributes to the creation of the heavier elements that are essential for the formation of planets and the development of life, like the elements found on Earth. Despite its vast size, Betelgeuse is not the largest star in the universe. There are other supergiants like UY Scuti and VY Canis Majoris that far exceed Betelgeuse in terms of volume. However, Betelgeuse is notable because of the information it provides regarding the final stages of stellar evolution. It is one of the best examples of a star nearing the end of its life cycle, making it an essential target for astronomers studying how massive stars die. The study of Betelgeuse has also provided scientists with critical data about the magnetic fields around stars. Like our Sun, Betelgeuse has a powerful magnetic field, but it is much stronger and more complex. The star's magnetic field plays a key role in its internal dynamics, affecting the flow of charged particles in its atmosphere. These magnetic fields create localized regions of intense activity, leading to the appearance of dark spots on the star's surface. These magnetic anomalies affect the way the star emits light, resulting in the periodic dimming and brightening that makes Betelgeuse such an interesting object of study. Interestingly, Betelgeuse's magnetic activity also provides insights into the broader processes of stellar magnetism. By comparing the magnetic fields of Betelgeuse with those of other stars, scientists can better understand the role that magnetic forces play in stellar evolution. Stellar magnetic fields are thought to be responsible for various phenomena, including solar flares and coronal mass ejections, which occur on stars like our Sun. Studying the magnetic activity of Betelgeuse allows astronomers to make more accurate predictions about how these phenomena may evolve in stars of different sizes and stages in their life cycles. While Betelgeuse is a dynamic and unstable star, it has managed to survive for many millions of years in its current state. It is thought to have formed billions of years ago, likely in a star-forming region within the Milky Way galaxy. Like other stars, Betelgeuse's life began with the fusion of hydrogen into helium in its core. Over time, as it exhausted its hydrogen fuel, it entered the red giant phase, undergoing the dramatic size and brightness fluctuations that characterize stars in this stage of their evolution. The fact that Betelgeuse has lasted so long in this phase is a testament to its massive size and the complex processes that govern stellar life cycles. The exact timeline for Betelgeuse's eventual supernova remains uncertain, but scientists believe it could occur within the next 100,000 years. This may seem like a long time, but in the context of stellar lifespans, it is relatively short. When it does go supernova, the explosion will be so powerful that it will release an extraordinary amount of energy, briefly outshining the entire galaxy. This supernova will send shockwaves through space, enriching the surrounding region with the elements that are produced during the explosion. These elements, including iron, nickel, and other heavy elements, will be scattered throughout space, contributing to the formation of new stars and planets. In addition to enriching the interstellar medium, Betelgeuse's death will serve as a dramatic reminder of the life cycle of stars. While the death of a star is often seen as a tragic event, it is actually an essential part of the cosmic process. The explosion of a supernova is a necessary step in the creation of the elements that make up the universe. Without these stellar deaths, the elements that form planets and life would not exist. As Betelgeuse nears the end of its life, astronomers are observing it more closely than ever. Thanks to the power of space-based telescopes like the James Webb Space Telescope, scientists are gaining new insights into the star's behavior and evolution. The ability to observe Betelgeuse in infrared wavelengths has revealed previously unseen details about its magnetic fields, its atmosphere, and its surface conditions. This data will help scientists make more accurate predictions about the future of Betelgeuse and other stars like it. Betelgeuse's eventual supernova will be a key moment in our understanding of stellar evolution, providing important data on how massive stars die. In the coming decades, astronomers hope to continue studying Betelgeuse and other stars in their final stages of life. By examining these stars, scientists will gain a deeper understanding of the processes that govern the birth, life, and death of stars, and how these processes shape the universe as a whole. The study of Betelgeuse is not just a scientific endeavor, it is also a reminder of the fleeting nature of life in the universe. Just as Betelgeuse is approaching its end, so too will other stars eventually burn out, and new stars will take their place. This constant cycle of birth, death, and rebirth is a fundamental characteristic of the cosmos. The death of Betelgeuse will be a powerful reminder of the incredible forces at work in the universe, shaping the formation of galaxies, stars, and planets. In the grand scale of cosmic time, Betelgeuse's life is a mere blip, but its influence will be felt for millions of years to come. The elements it has produced and will continue to produce in its final moments will play a crucial role in the future of the universe. Whether or not we are around to witness its death, the study of Betelgeuse continues to enrich our understanding of the cosmos and the life cycle of stars. The knowledge gained from observing this giant red star will continue to inspire astronomers and deepen our appreciation for the vastness and complexity of the universe.